Is it on? Okay, okay, it's very obvious this is a simultaneous equation. So this is simultaneous equation. Why? Because there are two unknown. You want to write down as well, so that you know in future when you see this, what you want to, how you want to tackle this question. Now, looking at the first equation, the unknown is at the base or at the power? Power. So the first one, the unknown is at the power. So what you want to do is you want to bring down the unknown to the base. Do that make sense? Okay, let's see how to do it. So from 1, 2x is equal to 8, 2y. How do I try and bring it down to the base? When I don't add log, I don't add log. Make all the same base. So base 2. So then something can happen. So 2x, this is 2 cubed times 2y. What's the next step? 2x equals to 2. 3, what y? Plus. So this is plus y. X equals to 3 plus y. So this is equation 3. So what's the difference between the last step and the previous step? The previous step, the power is on top. The last step, the unknown is at the base already. So this the power is, the unknown is at the power. This, the unknown is at the base. So then it's easier to solve. Now look at the second equation now. There is a log there. So you need to remove the log. Because you see 2y minus x, you can't do anything. But if you remove the log, then maybe you can do something. Now how do you remove the log here? How do you remove the logarithm? Means you change to the exponential term. Let's try. This log, there is a base. There is a base. This is base 10. So there is a base 10. So I write from 2 log 2x minus y equals 0. So this is base 10. What about the power? This is the power, right? So how will you write? 10 to the power of 0 is equal to 2x minus y. The worst thing that can happen now is you tell me 10 to the power of 0 is 0. It's 1, right? So this is 1. 1 equal to 2x minus y. Equation 4. Pause here. First thing. Now, whenever you see e, later on when you add, you usually will add log or ln. You add ln. Because ln e equals 1. Now, second thing. So we start. Can you combine these two together? No. Cannot, right? Because this is a minus. There's no way I can combine. And when you cannot combine the terms together, if I add log both sides or add ln both sides, it doesn't help. Understand? So if I cannot add log, cannot add ln, cannot combine, what's the next thing I should do? I should use S word. Substitution. Understand? So I need to try and use substitution. Okay, so let's try. So I will start. Let y is equal to ex. Now by writing this, I actually already settled the ex. But what about the e minus x? Not settled. Change it to positive. So I try and recall. A to the power of minus x is equal to 1 over ax. Oh, which means if I can write this, isn't this y? Again, if I look at this ax, so that means I can rewrite this equation. So I rewrite this equation as 8ex minus 7 over ex is equal to 10. Do you understand this part? Because the minus means I change it to a fraction. The minus means it's just over ex. Now if I look at this, does y equals to ex already settle both? Yes, right? Yes, right? So over here then you can write 7 over y equals to 10. Now from here, can you solve the equation? Yes. So I try by multiplying y throughout, or I try to make y the common denominator. I try to remove the denominator by doing, okay. How do I solve from here? What must I do? Change right hand side to 0, right? So therefore y will have two answers. And what is the two answer? 0. Negative half. Now how do I continue? Change back to the ex thing. Alright, I didn't show you about ex, so maybe now I will show you about the ex. It's very similar to any number to the power of x, but instead of adding log, now I will add ln. Because I remember ln e is equals to 1, so I try. Now over here, very simple. The x can come. Oh, thank you. Over here, the x can come down, right? So this one will be x. Ln e is 1. So then this is the answer. Of course, you must press your calculator. Tell me the number. Over here, what happened? No solution, right? No solution. Oh, you write NA. Okay, come. So the idea is this: if in the equation, again, if in the equation both sides got log, the base is the same or different? It must be same base. It must be same base. So this is condition 1. Condition 2 is x and b must be what? More than 0. Why? Why must be the x and b more than 0? If less than 0, what happened? No solution. I log a negative, no solution. Cannot. So this condition and this condition, then what I can say is x is equals to b, or something like the inside is equal to the inside, something like that. Easy to understand? Easy, Now, all of you look at this equation now. What you want to do is maybe you want to draw a line, write something here. So, the first thing is actually you need to combine two single log term on LHS, RHS. So let's try. The first one, is it already combined? Look at left hand side. Is it only one term? Only one term? Then after that check, is it the same base? Yeah. So what can you say about the inside? Same. So what's the next statement? X plus 1 equal 4. Simple, As easy as 4 minus 1, right? So x equals to 3. Hashtag. No trick. Just like that. Ridiculous, right? Logarithm actually very simple. So let's try the second one. Now, what is the first thing? What is the thing that I wrote at the side here? Combine single log. I look at this. How many log do I have here? 2. In exam hall, this is 4 mark, 5 mark one. It's one grade. It's that big. Alright, so this is 2 terms. How do I combine to one term? Times. Times product or quotient? Product, because it's a plus, right? So the next statement will be Okay. So from here, there are actually two ways to solve it. First way is the traditional way. Okay, I do the traditional way first, because traditional way longer. Traditional way says method 2. Method 2. Traditional means the right hand side also must be log. How to make this one? How to change to log? Log 10, 10. But if I log 10, log 10, this is log 2. Cannot leh. Log 2, 2, right? This is log 2, 2. So I can write log 2x minus 3x minus 4 equals log 2, 2. Where's the 1? Because there's a 1 here. Because there's a 1 here. Because there's a 1 here. So it doesn't make a difference. If this is a 4, then where's the 4? The 4 will be here, and the 4 can go up. Okay, I purposely write a 1. I purposely write a 1. So this is a 1. This 1 is referring to this 1. Okay, now, moving on. If I have log side, I have log. Then what can I say about the inside? Same. Which means I can say x minus 3, x minus 4 is equal to 2. Can you solve this? Can Can I say, simple this one x minus 3 equal to x minus 4 equal to 2. Can I say that? What must I do? Must expand, then bring over, become 0, then I solve again. Now, what is the alternative method? The method 1. Look at this. I have a single log, I have a number here. What is this number called? Base. What is this number called? Power. So I can also write, this is the base. This is the base. This is the power. And then I can write, simple. This one is 2 to the power of 1 is equals to x minus 3, x minus 4. Same. I'm trying to show you that they're the same. Depends on which method you prefer, then you use log. Okay? Stop the video here. Okay. Some of you are saying, there's a missing answer, x equals to 2. So when you solve this, x equals to 5, x equals to 2. Now, what you need to do is you need to check if log is a negative number. So, even though, I repeat, I even haven't started, I repeat myself. Even though you have two positive numbers, you need to reject. You need to reject if the logarithm is negative. Example, 5 sub inside. So 5 minus 3 is okay because it's 2. 5 minus 4 is okay because it's 1. But when you sub 2 inside, it becomes 2 minus 3. So it becomes log negative 1. So this is rejected. Alright, so if you are really worried, you want to write reason, then you write when x equals to 2, log 2 minus 3 equals to log 2 negative 1 equals to no solution. Repeat. This is the reason. Do you have to present your answer? No need. Unless they ask you, why do you reject? Then this is the answer. The answer is, when x is negative, x equals to 2, copy, log 2 bracket 2 minus 3 equals to log 2 negative 1 equals to no solution. So this is the reason why you reject. Okay? This is the first time we ever reject a positive number. Usually we reject the negative number. Only for log. For modulus also, remember? Modulus, when modulus something equals to x, the x cannot be negative. Okay, now, come to this example here. Now, first step, on top, what do you say? Change, combine into single log. But what's the problem here? Base is 9, base is 3. Cannot use product rule. Means I need to change this to same base. Same base, how to change? Log base 3. You see how I write? I usually will write that. Log, okay. After I write the new log base, then I start to think, which one I put on top? X. The number is on top. The old base is below. I remember like that. So number on top, new old base, denominator. So then I write 9. This is x plus log 3x equals 6. I got a problem here because from here, right, this thing is super unfriendly. I'm trying to simplify this. Bring over. I don't want that. Maybe I want to do something here first. Now, before I do something here first, maybe I'm going to ask myself, maybe I can remove the log. 9 is what? 3 squared. Oh, so this is 3 squared. So I have x, 3x. This is log 3 squared. After that, what can I do? Can the 2 come down? And if after my 2 come down, log 3 become 1. So then I write log x, log 3x, log base 3x. Now, there are 2 things you can do here. One is you recognize that the 2 is a half, and this is a half, and the half goes up, become power half. Another one is I want to remove the fraction. I think I like this better. I remove the fraction, there's a 2. So I what? Times 2, times 2, times 2. Follow? So if I do times 2, or some don't like, says, can I combine this with one single fraction? Then you cross multiply, also can. Can, So when you times 2, you will have no more 2, log base 3, this will be log 2, this will be 12. Can I stop here already? You know how to continue? Can I combine? Why? There's a 2 here, so what must I do? Bring up. Bring up become x squared. Can you follow? So I bring up become x squared. So I write slowly, you write faster. So you are ahead of me. So over here I will have it's always good to be slow and steady. So from here, how can I combine now? Combine become what? Log 3x cubed. From here, actually there are 2 ways of doing it. How do I do it? Different, But you check my answer, is it the same? Later. I haven't come out yet. Now, what do I continue here? Now, I just tell you the story. Can all of you look up first? One way is I can say 3 to the power of 12 is equals to x cubed. Then I cube root it. The second way is the 3 can come down. The 3 can bring over, divide. Then become log base 3x equals to 4. Then 3 to the power of 4 equals to x. Don't follow, never mind. I use the traditional way, So I write base 3, this is power. So I will write 3 to the power of 3 to the power of 12 is equals to x cubed. So after that, how do I find for x? Cube root. I cube root it, right? So cube root it, then x equals to 81. So when you look at the equation like this, with 3 different base, you want to change these numbers, the base with numbers. Hopefully you can remove the log. So how you can do it? Look at 343, it's actually 7 cubed. So once the log 7, and the 3 can come down, and this is 3. Same thing here, log base 9, 3. You want to use the change base one, then you change to base 3, and then you get half. And when you have this equation, you can just bring half over, and you can solve for the answer. Okay, so this is on page 9. I look at base 3, base 3, base 9. What do you think I need to do? Change the base, right? Which one? Oh, the 3 can use quotient rule, right? So the 3 can use quotient rule. So I try. Since this one I can use quotient rule, I will write log 3. Momo, help me. I have x, then minus 0.5. What do I write here? X over 0.5. X over 0.5. Now, on the other side, I have log base 9. What do you think we have to do? Change to base 3. Let's try. So this one I change to base 3. This one I change to base 3. You notice I always write a new base. Then I consider what to put on top, what to put below. What is on top? Wrong. You don't know. So the on top is always the number. The below is always the old base. I repeat. The on top is always the number. So what do I put? 5x minus 1. This is 9. Oh, this number come out again. Is it very familiar? This is the 2, right? This is 3 squared. So this is 2. Can I stop here already? Don't know how to do? I have the 2 here. What do you think you can do leh? Times 2 lor, or you cross multiply or you bring the 2 over. Once you bring the 2 over, can you compare the two things inside? Anyone can help me? Can I compare the things inside? I write first. So x over 0.5, 5x minus 1. How many of you think that, I can say x over 0.5 equals to 5x minus 1? Can I do that? Can Don't know. The base is the same but there's a 2 in front. How Bring up I bring up. So this one I bring up. If I bring up, I can compare already. Stop here. Let's start. Now, what is the mistake here? No mistake yet. Please copy for start. Copy for. Now, I want to combine. So my question is, can I choose my preference? Example, say I choose these two first. Can you tell me these two is what? Product or quotient? Product, right? So I write, I think this is equal to log 3 minus log 4 times 5. Then after that, can I combine these two together? Yes. What must we do now? What must we do now? Copy. Then after that, I write log 3 over 4 times 5. Yeah, some of you already start saying, wrong. So can I choose to combine these two? Then after that, I see, I combine these two, then I get this. Now, this is a big wrong. This is a big wrong. My suggestion is you do left to right. I show you the correct one, then you see why is it wrong. So if you do from left to right, you actually see log 3 over 4 plus log 5. If you combine again, what happens? You get log 3 times 5 over 4. What is the difference? The 5 is either at the bottom or the 5 is actually at the top. Which one is the correct one? This one, This one is the correct one. So, what actually went wrong is, when you combine the two together, you forget that this is a negative. I repeat, this is actually a negative. So this is negative. So if this is a negative, right, this is actually a divide. This is actually a over 4, something like that. But this is not a negative. So if you combine these two together, you're assuming this is a negative as well. If it's too complicated, never mind. Just remember, combine from left to right. Then you will not get wrong. And you don't. If you have three things, don't be ambitious. Combine first two. Then after that, you combine two. Then you combine two again. You combine two. Can